So hello everyone. So today we are going to start the second portion of the unit 3, which is the milling process. So here in this video we will discuss about the milling process, the different types of cutters, and up and down milling process. So for the introduction, milling is a machine process which is performed with the help of a rotary cutter which has several cutting edges arranged on the periphery of the cutter. So in case of milling operation, a cutter is used which has multiple cutting edges arranged around its periphery, which removes the material from the workpiece surface. So this operation, this cutting tool comes under the category of multiple point cutting tool. So it is a multiple point cutting tool which is used in conjunction with a milling machine. This process is used to generate flat surfaces or curved profiles and many other intricate shapes with great accuracy and having very good surface finish. So before starting the further discussion on the milling process, have a look at some videos which depicts the different types of milling processes with the help of different types of milling cutters. So in the first video we have a horizontal milling process where a rotary milling nylon workpiece surface. So this is the milling cutter which rotates and this is the workpiece. So during the contact this milling cutter, these edges on the milling cutter will remove the material from the workpiece surface in the form of these visible chips. The second video is of the face milling operation where a face milling cutter is used which has the cutting edges arranged on the periphery of the face and which removes the material in the form of chips. So this is the milling cutter which is acted vertically and these are the chips which are removed from the workpiece surface. In the third video a CNC machine is presented which is producing a slot in a metal. So this is the representation of the CNC milling machine where a typical slot is being generated on the workpiece surface. So this is the milling cutter which is generating the slot in the workpiece surface very easily. So starting with the category of the milling cutters, we have different types of milling cutters as the slab milling cutter, the face milling cutter, the end milling cutter and so on. In case of slab milling cutter, the cutting teeth or cutting edges are arranged around the periphery of the cutter and this type of cutter is used in the horizontal axis machine. So this is the representation of the work being machined with the help of slab milling cutter. These are the teeth. These teeth removes the material in the form of chips from the workpiece surface. This is the end milling cutter which is operated in the vertical axis machines and these are the cutting edges. This is the face milling cutter which is again used in the vertical axis machines and these are the cutting edges which removes the material from the workpiece surface. This is the representation of the material removal in case of face milling cutter. Next cutter is the slot milling cutter which is used to generate the slots on the workpiece surfaces. This is again operated in the horizontal axis machines where different shapes, different thicknesses milling cutters are used to generate the slots. In this diagram, three different operations of the cutting are depicted. In the first one, a single shaft is having two parallel slot milling cutters which are used to generate this type of surface. Here a slot milling cutter is generating a cavity in the workpiece surface. Here a very narrow width sawing or parting the milling cutter is used to part of the workpiece surface. These are the representations of the form milling cutters, where a particular form of the teeth generates the complementary shape on the workpiece surface. In this case, these are the projecting ones which generates the groove. These are the inclined teeth which generates the inclined cavity in the workpiece surface. The milling cutters can also be used to generate the gears. Here, the gap between the two teeth is generated with the help of a particularly shaped teeth on the milling cutter. This is again a representation to generate the gap between the teeth. So, these are the different cutters which are used to generate the different shapes on the workpiece surface. Next is the gang milling process, where a single shaft has two or more than two cutting edges. So here in this case we have, rather it is three or more than three. Here a shaft has three milling cutters arranged which produces a particular shape like this. In this case, four milling cutters are arranged which generates a shape like this inclined angle surface, the flat one, this vertical one, and so on. So this is the representation of the gang milling cutter. Next is the straddle milling, where a shaft has two slot milling cutters mounted on it. And when this cutter rotates, this workpiece is fed on it, which generates a flat surfaces like this on the workpiece surface. So this is the straddle milling operation. Next we have the milling processes. We can divide all the milling processes into as up milling and the down milling operations. Up milling is also known as conventional milling, and down milling is also known as the climb milling. In case of up milling process, the direction of the rotation of the milling cutter and the workpiece are opposite to each other, and in the down milling the direction of the rotation of the cutter and the workpiece feed are in the same direction as represented in this diagram. Here the cutter is rotating clockwise in this direction and workpiece is being fed against the cutter. So this is up milling. Here the cutter is rotating in clockwise direction and workpiece is being fed in this direction, which is same as that of the direction of the cutter. So with the help of these two operations, several differences are there, which includes the surface quality, the fixture required, and the thickness of the chips.